What's up, Covalence friends? So, as I'm sure many of you have seen by now, Luke has been going through an algorithm series, and one of the ones he touched upon recently was the classic FizzBuzz. And in that video, he mentioned a collaborative effort with me, and the reason he suggested that is because I like to joke with students about creating your own algorithm solving server using Express. And that way, in the context of an interview, you could just make a fetch request to your own server to a FizzBuzz endpoint and have it give you the answers back, which is kind of funny and kind of cheeky. And if you manage to accomplish that, you'll make your interviewers laugh and you'll be a really memorable candidate. And they'll be like, okay, this guy's, going to do great here with us. And if you do that, not only is it funny and more memorable, but you actually have to code out the problem itself and know it really well to be able to allow it to be, dynamic. And the reason why I say dynamic is because what if they're like, okay, guy, you're funny, pal, but how about you make the numbers 3 and 7 and 21 instead of the classic 3 and 5 and 15? And what if they're like, okay, and in addition to that, how about we use the words pizza and pie and pizza pie instead of fizz, buzz, and fizz buzz? Well, they might be like, okay, we've got this, interviewee. They are, pinned down and they have to really think on their feet for this. But what if you have query parameters that make the entirety of your FizzBuzz solver dynamic? And you pull a second fetch request on them. And I mean, that would just be an incredible endeavor to pull off in the context in an interview. And of course, you would want to solve it right after that, but I think that would really make you an incredibly memorable candidate. And I'm looking forward to this video, 6 months, a year, 2 years, 5 years down the line, when somebody comments and they're like, Andrew, no way, I did this in an interview and they laughed so hard and they gave me an offer before I even left the interview room. I'm going to be just absolutely elated to hear that. So, it's kind of funny. And at the very least, if you set this project up, you practice the algorithms yourself. So like win-win. But let's go ahead and start making our own little algorithm solving Express server. So I am so nitpicky about directory names, he says, but let me show you my my demo folder. Maybe not. Let's go ahead and initialize this as a node project. And let me go ahead and install Express and also the cores middleware, because I'm going to be testing everything locally, which is fine, but if you try to make the request from some other origin, like if you have your Express server deployed on some cloud, platform somewhere, you're not going to be making a fetch request by like SSHing into like that specific server and making like curl requests via the command line. No, you're going to be like fetching from like Code Sandbox or some other, interpreter that they have, some other environment they have set up for you. So we definitely want to make sure that we have cores enabled on our app so it can talk to your server from afar. So we'll go ahead and get our server set up. And let me see my zoom level. Whoops. There we go. That's a little better. So we imported Express. We're instantiating our Express app. And we're telling our app to listen on a specific port. And just because this is going to be deployed on a cloud platform, we're going to have it listen to a port environment variable, which is what they usually will do. They'll inject that, and we'll listen for it here. And if one's not provided, as in I'm developing locally, we'll just default back to 3000. So we have the most bare bones Express web server setup, but I do want a little more functionality, like having something actually work. So let's go ahead and get cores installed, imported, and applied, that is. Alright, now I have cross-origin resource sharing enabled. And I'm not sure what I'm going to do with this. This might just be a FizzBuzz solver, but you know, hey, if you guys want to see more videos like this, please go ahead and subscribe and let me know in the comments if you want to see some other algorithm challenge abstracted out to an Express endpoint that you can just make a fetch request to and get the answers from. So and just for organization's sake, since that might be a future possibility, in case I do want to do other videos, or if you do want me to do future videos, we'll just make our application kind of scalable. So we'll go ahead and require Express here. And we'll go ahead and just make a router here and just immediately export that out. And what I like to do is I just like to make, you know, the minimum viable element in a file that I can create and export, just so I can get everything linked up and handled. So this router index is now done, meaning I can go ahead and import it here. And I import that routes index file as algo routes. So here I'll set up my app to use the path /API/ algos, maybe algo, because I'm going to be like API algo FizzBuzz. Not in love with that path name. I'll go with algos, plural. Man, like I said, y'all, variable names, folder names, like, you know, the absolute worst. API algos, plural. Or maybe I should do algorithms too, because like yet again this is also something that you're going to try to be remembering in the context of an interview, so maybe having like more verbose, like the most descriptive variable names possible is the better solution. And I'm always a fan of, you know, descriptive, but I do like concise and descriptive together. However, I think having the word spelled out in its entirety is going to be a little more helpful to remember. So API algorithms leads us to this index file, and then here we can just make our individual routers for every like algorithm that we want to solve, so just for organization's sake. And I'm just going to copy paste this code to, you know, make a new router for FizzBuzz, because yet again I just like having that minimum, you know, viable, you know, product, that minimum setup established. So this file does contain an Express router that is exported, therefore on my router index, where we currently are, I can import it. So every URL is concatenated, so in order to get into this file, we have to start with API/algorithms. So in order to get into this file itself, it has to start with API algorithms of FizzBuzz. And we have our router index set up, and now it's nice and scalable. in case I want to add other solutions. All I have to do is write the actual like code in there, and to get everything linked up, just do an import here and another router.use, and everything is set up exactly how we need it to be. So I'm making a GET request here, just at the root URL. So this is going to be, /API /algorithms /FizzBuzz. And I'm just going to go ahead and like code out the manual hard-coded version so we can see that first, and then maybe we can start making it a little more dynamic. So for FizzBuzz, it usually involves like console logging with each line, but for most algorithm challenges, you do return an answer in your function. And for FizzBuzz, you probably would just be returning an array of answers, and I mean that's exactly what we're going to do here. We can't just like return per se, because this is a fetch request, a network request, so we're sending back some JSON data ultimately. So we'll do that, and I'll do the classic FizzBuzz here. So we'll start at I equaling 1, and we'll go until I is less than or equal to 100, so it's going to include 100, and not 1 plus plus, I plus plus. So if I is divisible by 15, we'll go ahead and push into answers, FizzBuzz, getting our edge case accounted for first and foremost. And I'm going to do some copy paste here. So that copy paste is nice because I can just shortcut stuff really, really concisely. So if it's divisible by 15, we have our edge case accounted for where it's divisible by both of our numbers. If it's just divisible by 3, we'll just do fizz. If it's divisible by just 5, we'll do just buzz. And if it's divisible by none of the above, we are going to go ahead and just push I into there. And that actually gives us just a bare bones FizzBuzz solver. If they don't want you to change anything up, like that's it. We have both the algorithm accomplished here that you've now practiced, and we also additionally have, well, a web server that solves it for us. So let me go ahead and make a start script for our code. And that will just be node server.js. I'm just doing a plain JavaScript project. I don't know why I didn't do TypeScript when like the last gajillion projects I've done have all been TypeScript, and I always talk about that in every video, how it makes things nicer. But so I hit up API /algorithm /FizzBuzz, and we get an array from 1 all the way over to 98, 99, 100 with the accurate FizzBuzz solution within it, which is pretty great. So, this alone is cheeky, but if they throw those curveballs at you and they're like, hey, instead of fizz and buzz, do pizza pie or some other, word. Well, we don't want to be caught, off guard. So we can utilize query parameters to help us. So query parameters just allow us to have a dynamic amount of arguments in our URL. And we can also just short circuit to provide some default options. So if any are missing, we just kind of assume the default case, which is great. So what we could do is, let's do the start and stop numbers first. So we're going to assume somebody is putting start equals some number in the URL. So that's going to get injected into our rec.query object as the start property here. So we'll extract it out as the variable start. And since this is something coming from a URL, it's going to get coerced into a string. So every number that we interact here, so our start, stop, number 3, number 1, number 2, all of those must be parsed to an integer. So we'll call parse int on this. Now, regardless of whether or not I'd have to cast something to a number here, I still need to have some default options as a fallback, because what if this is undefined? Well, parsing undefined yields not a number, which is a falsy data type. And undefined is also a falsy data type for our strings, but regardless, what we need to do is just short circuit and say, okay, well, if the element on the left side is evaluating as falsy, let me go ahead and return whatever is here. So if they provide a number in the URL and we can parse it successfully to an integer, great, we use that as our start. But if for any reason, if it's just not there, or maybe I say start equals pizza, trying to parse the string pizza into an integer returns not a number. And so any crap value, anything falsy, just lets us fall back to 1. So we have some nice safe code, but also some really configurable code. And then I'm going to do the same thing here for a stop. And we'll go ahead and set that at 100 as the default. So we'll replace I equals 1 with I equals start, and less than or equal to stop. So it's kind of starting to feel weird seeing your FizzBuzz solution not have like hard-coded numbers in it anymore. But, no matter what, if these are missing, it's still going to have the exact same behavior with those default values over here. So I'm resetting my server, and I'm going to refresh here. I'm giving no arguments, and we are going to see the exact same data. However, if I do add in a query parameter and say start equals 4, we're not going to see 1, 2 fizz. We're going to see 4 buzz fizz as our starting numbers. 4 buzz fizz. And if I say and stop equals 16, we'll see 1 fizz buzz, but that's it. So we go from 4 to 16. So all of that is very configurable. However, if we leave it off, just make a request to the bare FizzBuzz endpoint, we get the classic default one. So that's nicely handled for us. Now, what if they say, okay, new words. We're not doing the words FizzBuzz. We instead want to do, Well, as I think of what I want my default value to be, I can at least write the code for, what it should be coming from. I'll just stick with pizza pie. That's one I think I alluded to earlier. So we'll let word 1 be pizza. And, we're not parsing to an integer here, but the short circuit concept still applies. If rec.query.word1, if word1 is not in the URL, this ends up being undefined. Undefined is falsy, so instead we keep on evaluating this chain here, and we return the next truthy value, which is pizza. So if I leave out word1, it is pizza. Or wait, no, sorry. The default is going to be fizz. Sorry, if you want to use pizza as your variable, then yes, that applies, and I'll do that in our example. I don't know why I was thinking that needs to be the default value. No, you don't want that for the default. We're doing the classic FizzBuzz for the default. Silly me. So word 2 on that matter will be buzz. And then I don't foresee them throwing you for this kind of loop, but what if maybe they wanted a completely different third word? So they said, okay, do fizz buzz and then spaghetti instead of FizzBuzz. Well, Cool. I mean, we can have a word 3 in the URL. That's fine. We can accommodate for that, but it's a little silly. That one I wouldn't see happening, but still, we can accommodate for that. And otherwise, what we'll default to doing is just concatenating word 1 and word 2 together. So if I actually did select pizza and pie for word 1 and word 2, and I left word 3 blank, it would end up going to pizza plus pie. So I would get pizza pie for word 3. So we can now start replacing these strings with these placeholders here. So this is going to be our word 3. This is our word 1. And this is our word 2. And finally, if they do decide to throw you a curveball and say, let's change up the numbers, well, if we have 3, 7, and 21, or maybe not even 21, maybe they want this to be a third arbitrary number that is not, you know, the multiple of number 1 and 2. We can accommodate for that, just like how we did with the words. And I am going to be verbose with these variable names too. So like we could say like divisor 1, but that's going to be a little harder to remember. So what I would do is say number 1. And that 2 is also going to be a number. So we do need to parse that. And if we leave it out, number 1 is undefined. Parsing undefined to an integer yields not a number. Undefined is not a number, which that is falsy, so therefore we can fall back to 3 here. And here we have number 2. I know some of y'all snickered at that. Which does the exact same. And number 3, yet again, kind of like the above, even if they do decide to throw you a lot of curveballs, this is just not one that I foresee happening. However, it's an extra line of code that you are fully equipped to handle. And so if you do have a curveball thrown where 3 is not a multiple of 1 and 2, your code accommodates that. Otherwise, we can just default it to being number 1 times number 2, and that works out beautifully for us. And now we just replace all of these divisors here with our corresponding numbers. And now we have a fully fledged and extremely configurable FizzBuzz. So let me restart the server here, and let's go check out the functionality. So by itself, still returns the exact same thing, 1 through 100 with the classic FizzBuzz. If I decide to say like start equals 3 and stop equals 70 and word 1 equals light year. So we'll have light year buzz, I guess. Light year buzz. We have all of that accessible to us. And if they want to change up, you know, the numbers, number 1 is equal to 3, and number 2 is equal to 7. That means we will have 21 be our, you know, FizzBuzz. And I change the strings back to their regular things, so it's start, stop, number 1, number 2. But, you know, we can put any permutation of these arguments in any order that we like, and it is fully adaptable to that situation. So here we have 21, aka FizzBuzz, because that is a multiple of 3 and 7. The next one would be 42, FizzBuzz, etc. 63. Now, one of the tricky things that I talked about is that this might be a little harder to remember some of the variable names, some of the query parameters in the context of an interview. So the nice part about the organization we have is that we have like a separate distinct file for every individual algorithm that we potentially want to solve. So we could make like a help endpoint here. What we use to maybe like spit back out some context about the query parameters that are available. And even we can even say like what the defaults are. So if I do this, so we have our start and our stop, and then we can define like all of our words. I don't know why I copied start so much. So we're just trying to give ourselves like the maximum amount of information possible, just in case we forget some of the arguments. And technically, we don't have this defaulting to FizzBuzz. We have it defaulting to concatenating what word 1 and word 2 are, because if you make your own word 1 and word 2, it's not going to be FizzBuzz manually down here. Everything is fully dynamic. It will be concatenating whatever you put as word 1 plus word 2. And then, let's see. Here we're going to change word to number. We'll change string the number of the first divisor. We'll just leave that there. So just, I mean, I'm just setting up strings here, like just a bunch of find and replace. But let's see. We can put in an example URL even if we wanted to. So what we could do here is just copy in our sample URL. The host name will be different. Ooh, actually, what you could do is concatenate the host name here. That's not going to work for me in development, I don't think, because I think it'll just say localhost and not localhost :3000. But if you do have this deployed on a cloud platform, you know, this might be like yourapp.herokuapp.com. So it would be like the full host name. And that means that example would actually be like a clickable link. So we just have that as a help endpoint for the FizzBuzz router. It's like API/algorithms/FizzBuzz/help. If we have that, it's going to be the giant response here, letting us know, what variables are available. So just in case you do forget, the bare one, API, algorithms, FizzBuzz, but they're like, okay, switched up. You can be like, okay, let me check this real quick. API, algorithms, FizzBuzz, help. Let's see. Let me shut down my server and restart, just in case I didn't save. There we go. I just didn't save my code. All right. Yeah, crud. So like I said, it's not exactly going to work on local development, but that will work in production. But we have every argument possible in our query parameters, and we even say what the default values are. So if I do change up my code here, temporarily to be instead of rec.hostname, and I need to shut down and restart my server. There we go. Now we actually have a clickable link to some actual response of the actual utilization of it. So that's really, really cool too. And that way, if you go to your help page and they're like, okay, how do you do this? You can just take that, change up what you need, and you already have a lot of context in the URL. So, but yeah, so that's about it. I just thought maybe the help router would be the help route would be helpful, beneficial in the event that, given all of these possible parameters, we might forget one of the words, but help is something we can always remember. And if I do decide to, if you guys are interested in me doing more algorithm solving endpoints, I think it would be beneficial to have a help endpoint for every request, and that way you kind of know and have a predictable, reliable structure. So /API/algorithm/algorithm name gets you that bare endpoint, or /algorithm name/help gets you additional context about it. To recap as well, for the actual endpoint itself, we have query parameters, and a lot of them, but it makes our entire application dynamic. So we start off with this array of answers that we end up returning, sending out as our network response, that is. And any query parameters that are in the URL, we attempt to take as arguments. And, we want this to be really, really, really dynamic. So all of these are optional. And so we do have fallbacks. We have these short circuits in place, setting a default value in the event that these are undefined or falsy for any reason. So if it's undefined, or if it's not a number, because if this is undefined first, but we try to parse it to a number, it becomes not a number. Falsy, so we fall back to 1. So if I leave it out, it's 1. If I put a number, it becomes that number. If I put the word spaghetti, it falls back to 1. Same thing here, but for 100. Same thing here for 3, 5, and 15. And then the strings, if it's undefined, we use fizz. If it's undefined here, we use buzz. If word 3 is undefined, we use fizz plus buzz, aka FizzBuzz. If we define something for word 1, like pizza, and define something for word 2 as pie, but we leave out word 3, it falls back to word 1 plus word 2, so pizza plus pie, aka pizza pie. And that allows us to eliminate every single variable inside of our for loop. So we go from start to stop, including stop, and we're checking to see if it's divisible by number 3, and if it is, we push word 3. If it's divisible by number 1, we push word 1. If it's divisible by number 2, we push word 2. Otherwise, we just push I. And ultimately, we respond with our answers. So I hope you guys enjoyed this video. And like I said, please I want to hear, weeks, months, years down the line, if you ended up doing something like this in an interview and it made the interviewers laugh like crazy and you got an offer on the spot. Because that would just be so amazing and would absolutely make my year. But at the very least, this project does make you practice FizzBuzz, and it does make you, create variables for every little minute operation. So you're not just doing like rote memorization of the algorithm itself, but instead you're forcing yourself to understand and think, oh, why do I have to do each specific step in a certain way? So it's kind of beneficial to do this anyway, but it also would be really, really funny to pull that off in the context of an interview. So if you enjoyed, please subscribe, and let me know in the comments if you'd like to see another video like this. Otherwise, I'll see y'all around.